Let's go. Hey, everybody. I'm Bogdan. I'm one of the co-founders of DatologyAI, and I run the engineering team. So the best and most innovative companies in the world train their own models on their proprietary data. Turns out this is fairly complex. They have petabytes of data. It takes a bunch of time to iterate over this, and it's quite expensive to figure out what is the right data to put in your models. So this is where we come in. We provide a data curation as a service. We basically build this product that deploys on your cloud environment. You point it at your data. We ingest, filter, dedupe, transform, generate synthetic data, everything that needs to happen in order for you to get kind of the best pre-training or mid-training data set. And we basically give you back a data set, and whenever you train on it, you see the following three things. You see that you can train much, much faster than before. You get improved performance, and it helps you reduce the cost of deployment. So let's jump into each one of them. So what does it mean to train faster? It means that with a data set that was processed by the Datology pipeline, you can train a model which is about 12 to 18 times faster than before. That's on text, and it's even better on image text. Where most of our customers are actually, they just want better models. It turns out that if you use the same amount of compute and you put this kind of high-quality data set through this, you get models which are much, much better. So one of the best data sets out there is something called DCLM. It's made by a lab at Stanford. They have like 40 master students working on it. And that's the best that open data has to offer. And we beat that by about 4 percentage points. Another way to think about it is that if you were to train 10 times as much on DCLM, you would get very close to the performance of using 1x the compute that the Datology data set would give you, but you wouldn't get even close. Like, you can continue to train indefinitely. You wouldn't be able to match this performance. By the way, this performance is zero shot on a basket of about 25 kind of standard evals. Same thing with image text. So with clip models, we have this blog post where we show that we basically beat SIGLIP2, which is something that comes out of Google. They use about 10 times more compute to train this model, and they kind of pull all the training tricks in the world in order to make this. And what we do is that we just do data curation. We take the OpenClip vanilla repo, which is 4 years old, and we beat that by a good margin by just curating data. So that's kind of the bread and butter of how you get performance. And finally, reducing the cost of deploying this. So what we show is that you can train models that are much, much smaller, that either beat the performance of your current model or sometimes even exceed it. So for text here, for example, we train a 1B model that beats kind of 2.5 to 3B models on DCLM. So if you think about the cost of inference, you can basically deploy a model that is as performant as your model today, but much, much smaller in terms of parameter count. And if you think about the total cost of ownership of your models, then they're very much weighted on inference. So that's the value that you get by training on better data. You get to train faster, you get to the best models possible, and you can even reduce the cost of your overall inference cost. So how does this work? Well, turns out this is a frontier kind of research problem. That's what we do all day. We try a bunch of things that mutate data sets in various ways and kind of figure out what works, what doesn't, and we've been at it for about a couple of years, and I think we got to some really impressive results. So we think about how data is duplicated, like how much redundancy you need in your data set. What are the categories of redundancy? How do you want to filter your data set in various ways? You can have heuristic filters, you can have model-based filters, you can dedupe your data semantically. We generate a bunch of synthetic data. So there's this blog post that we wrote recently in which we show that actually synthetic data can break the data wall. So by generating synthetic data using a specific type of recipe, you can get to models that are much, much better in quality. So all of these things together kind of make our solution. Each month that passes on, we do more research, we put this into a product, and we ship it to customers. My other two co-founders is Ari and Matthew. They couldn't be here, unfortunately. So they're both ML researchers, spent a bunch of time kind of publishing on the subject. So kind of deep roots in the research world. Ari won a Best Paper Award in Europe in 2022 on a paper that kind of sets the foundations of the space. We're backed by AI luminaries, including Jeff Dean, Jeff Hinton, Jan LeCun, a bunch of others. We've been around for a couple of years. I think one of our customers that we've been public about is this company named RC. They've trained this model, AFM 4.5B, that kind of beats Gemma 2 and is competitive with the Quen 3 at the same kind of level of the same size. And right now they're training this really cool series of models called Trinity, which they're all very, very close to being kind of state-of-the-art for the size that they're at. This is still training, so we'll have to see what they get in the end, but the initial the initial results look very, very promising. So if you want to work at the intersection of data research and data engineering, that's the place to do this. We work on cutting research, and we put this into enterprise-ready solutions, and we ship this to some of the largest enterprises in the world. I think I was